Okay, so we come right down to it in this short course. One of the things that we like to do at the end of Calc 1 is deal with U-substitution, and in particular with respect to exponential and logarithmic functions. So I want to work out in this video a few examples of those so that we can see how it works in action, if I may. The most common U-substitution type question involves the exponential function where there's some power that isn't x, and that's always a dead giveaway, because what's the derivative of x cubed? Oh, look, there it is. And so you think to yourself, wait a minute, that's here. So we gotta be in good shape here, and we are. This integral, so the x squared dx is 1/3 of du. E to the x cubed, that's e to the u. And so we ask ourselves, what is that? Well, the integral of e to the u is e to the u plus some constant. And we weren't given the question in terms of u, so we don't answer the question in terms of u. We answer the question in terms of x. This is by far the most common way to do this. You should know that it works even in scenarios like this. Again, the power on E is not X, and so we wonder aloud, oh look, there's our x dx. So we know that x dx is a half of du. And then the question is, what is that? What is that? Well, that's this. And we know something whose derivative is this, don't we? And because we know something whose derivative is that, we have our indefinite integral, a little bit of algebra, recognition that e to the negative u is 1 over e to the u plus a constant. If there had been limits of integration, we could have done this with those limits. No problem there. There's nothing fancy here. The other kind of question that pops up semi-frequently is the kind of question where you have some denominator and your numerator is basically that. Anytime the degree of your numerator is 1 less than the degree of your denominator, you start thinking, is this the u we're looking for? Maybe. Because this is x squared plus 1 dx, and x squared plus 1 dx looks like it's 1/3 of du. So we go 1/3 of du. The fraction that's left over is 1 over u. This is u. From where to where? Well, we can do that. When x is 1, u is 1 plus 3. And when x is 2, u is 8 plus 6. And we remember that the antiderivative of 1 over u is the natural log of u, technically the natural log of the absolute value of u, evaluated between 4 and 14. So this is 1/3 of natural log 14 minus natural log 4. But that's never the way you're going to see it in the back of the book. In the back of the book, you're going to see it like this, because that saves space. Natural log of 7/2. Why? Because you'll remember that that minus means that those logs being subtracted came from the arguments being divided. That's the quotient property of logs. So this is 14/4, which is 7/2. Sometimes they'll write it this way, and that requires you to remember that this 1/3 that's in front could have been a power. That's the power property of logarithms. So I'm hopeful that this is helpful to you. This is similar to, but different from, integrals like this. Same kind of game, except that eventually you get some version of this. This is not a log integral. This is u to the negative 2, and the antiderivative of u to the negative 2 has to do with u to the negative 1. The only situation where we pull out the log the only situation where the log function becomes important is when there is a u to the 1 in the denominator. That becomes a key for us. That's the only situation where we reach into our box of tricks and think it's time for a log. This is not a scenario where a log pops up, and I hope that that is helpful to you. Thanks for sticking with us through the short course. I hope that this has been of some help to you, and we wish you all the best going into the fall.